Now let us look at the next problem. A small block of mass 0.1 kg lies on a fixed inclined plane PQ, which makes an angle theta with the horizontal. A horizontal force of 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary if, okay, so we have to see which of the four options is or are correct. Okay, now let us try to make the FBD. So 1 Newton force is acting and the mass is 0.1 kg. So the weight of the block is 1 Newton. So if we make the FBD, so 1 Newton is acting in this direction and 1 Newton is acting in this direction. Okay, let us say this is force F. So if this angle is theta, then the angle that the component of this force F makes along the incline is F cos theta. Okay, and this is weight mg. So the component of weight along the incline is mg sin theta. Okay, so the net force acting along the incline is, one is F cos theta acting upwards and mg sin theta acting downwards. Now depending on the relationship between F cos theta and mg sin theta, we will come to know that this block is stationary and the force is acting either in downward direction or in upward direction, and that will be only a relationship or will be dependent only on the angle theta. Okay, now let us look at the first case. Let us say the angle is less than 45 degree. Okay, so if angle is less than 45 degree, that means F mg sin 45. Okay, now mg and F both are same, both are 1 Newton. So sin 45 is less than cos 45. That means F cos theta is more in magnitude in comparison to mg sin theta. That means this body is tending to go upwards, but it is stationary because of the force which is acting in the downward direction. The frictional force F will be equal to F cos theta minus sin theta. Okay, so the frictional force will be acting in downward direction if the angle is less than 45 degree. Similarly, if the angle is more than 45 degree, then F cos 45, that is cos 45, will be less than sin 45, which means that this component mg sin theta is more in comparison to F cos theta. That means body is tending to go downwards, but because of frictional force, it is not, it is stationary. So the frictional force is acting towards Q. Okay, if the angle is more than 45, and if the angle is exactly equal to 45 degree, that means mg sin theta is equal to F cos theta. And in that case, since the two forces, they are balancing each other, so there is no question of frictional force arising. The frictional force will be 0. Now let us look at the four options that we have. The block remains stationary if theta is equal to 45 degree. Correct. Okay, whether friction is there or not, it does not matter. If angle is exactly 45 degree, so it would be always stationary. If theta is more than 45 degree and a frictional force acts on the block towards P, no. If the angle is more than 45 degree, then the frictional force is acting upwards. So this is incorrect. If angle is theta is more than 45 degree, then a frictional force acts on the block towards Q. This is correct. And if theta is less than 45 degree and a frictional force acts on the block towards Q. Okay, so if angle is less than 45 degree, that means the frictional force has to act towards P. It has to act downwards. So this is incorrect. So correct options are A and C.